Okay, can you help me read the title of our unit, our last, not a unit, our last skill, okay, of this unit? McKenna, what's our title for our last skill?
Inverse functions.
Yeah, inverse functions, okay? I want to come back to example 1 really quickly. Can you please help me read the inverse relation definition? It's not here. So Grace, can you help me read the definition of inverse relation?
If a relation pairs element A of its domain to element B of its range, the inverse relation pairs B with A. So if AB is a point of relation, BA is a point of its inverse. The domain and range switch.
Yeah, okay, so let's talk about that really quickly. Can you see it says that the domain and range are switched? Okay. So if it used to be an x value in the regular, in its inverse, that same x value will be what? The y value. You're right. Okay. So for it to be an inverse relation, the x and y value will switch. Now, let's talk about relation. Is a relation the same as the function? Because down below is the definition of inverse function. So let's go back in Algebra 1. I know. So far, what's the definition of a function? What was the definition of a function? Every unit you have studied in Algebra 2 so far, by the way, has been a function. So what was the definition back then in Algebra 1? What was the function?
X equals y.
Every, not x equals y. It will have an x and y, input, output. But what about x and y? What about inputs and outputs? What was it? Okay. From the very beginning, we graph lines. We review for semester. Is line a function? Is linear a function? Okay. Then we went and studied, we graphed parabolas. Are those functions? Okay. Then we went on and graphed absolute value. Do they make what shape? Not a U. Absolute values make a V. Are those absolute value functions a function? Yeah, it says function. Then we went on further and we did reciprocal functions. And 1 over x. Then you have those curves, right? One on the top, on the bottom. Is that a function? Yeah. Then we went on and graphed most recent one, radicals. For those functions? Oh my. And then we also graphed x to the third. Was that also a function? So we graphed lots and lots of functions. Well, what on earth is a function? The equation will involve x and y. What about it? What about these special x and y? We're going to review functions really quickly. It may or may not. Okay, let me give you 2 graphs and you can tell me. I'm going to make the first one. Check out this purple one. I just sketch it. There's no exact location or point. Is this a function? Why is this a function?
It goes on forever. There's 2 arrows at the end of the line.
I'm actually going to change that up. Is that a function?
Yes.
It's still a function. What do you see? What is, okay, then I'm going to sketch another one then. Make up another one. Is this a function? Is this a function? The purple and the red, okay? How are they? What's the difference? We know this is a function. Is this a function? What kind of test are we doing to check if it's a function? The pencil test, right? What about the pencil? What do we do with the pencil? The pencil test, right? What do I do with the pencil? I'm going to go vertically. Every or any vertical line that I draw, a function may only intersect what? At most? Once. It doesn't have to intersect, but if it does, at most what? Once. So let's look at the purple. I drew a bunch of vertical lines. Is there ever a location of x that it intersected twice? No. But look at the red. Did it? Yeah, so the purple is a function, but the red is not a function, okay? So you remember a function was every input may result in at most what? 1 output. So let's look at the red. Let's pretend that this is like a -10 over here. If I put in -10, how many outputs do we get? 2. So that's why this is not a function. Now look at the purple. Let's pick like -5 for the sake of simplicity. If I plug in x is -5, how many y do you see? Just how many? 1. So a function, remember, one input can only have at most one output. So now let's go and read the inverse function definition. Can you, Brooke, help me read the inverse function definition?
Function is one-to-one, its inverse is the function. If both the relation and the inverse of functions are inverse.
Okay, now we have to go even more into the function. Between the purple and the red, we decided the red is not a function. Can you guys agree? So right now, if not a function, then it's not a one-to-one function, okay? Now the purple, is that a function? But is it a one-to-one? Is it a one-to-one? No, what kind of test do we have to use for it to be one-to-one? A horizontal line test. So does this pass a horizontal line test? No. So right now, this is not a one-to-one. Now in inverse function, we have to start out with a one-to-one function. Then its inverse will also be a one-to-one, okay? And here's why. Let me just make up something really quickly. Let's say that I have this graph, okay? What kind of graph is that? I just made that up. What kind of graph is this? It's a square? Square root. Question number 1, is that a function?
Yes.
Great. Let's go even further, more strict. Is it a one-to-one function?
Yes.
It is. So if it's a one-to-one function, when I find its inverse, the inverse will also be a function. Okay. So we're going to go to example 1 and figure it out. Graph on the same coordinate plane, f and g, and f of x is 2x plus 8, and g of x is 1/2 x minus 4. I have multiple colors, so I'm going to do f of x in red, and then we're going to label it. So graph out f of x equals 2x plus 8. Brendan N., what kind of curve, what kind of graph are we expecting for f of x? A line. Very good. Let's start graphing this line. Where do we start? Gemma W. We're going to graph this line. Brandon said it's a line. How do we graph that line? F of x equals 2x plus 8. Put a dot where? 8. 0, 8. That means go up, right, guys? So 0, 8. Very good. Miss Amanda, what's the slope?
2.
2. That means we go up or down? Up 2, right 1. I'm out of space. Can I also go down 2 and left, right? Do as many dots as you can, guys. The more dots you make, the straighter your line is. Take out your straight edge, connect those dots, and label it f of x. Okay, anytime you have multiple graphs on the same coordinate plane, we have to label which one's which. So that's our f of x. We are going to do g of x. Sorry. If you just have a pencil, labeling is sufficient. Okay. G of x, how do we start? What kind of curve or what kind of graph are we expecting? Victoria, on g of x? It is a line. Very good. Okay. Let's start. Maddie R., can you tell me how should we start graphing g of x?
0, -4.
Perfect. 0, -4. There's that one. I'm actually going to label that 0, -4. And then we're going to use the slope. Brandon C., what is the slope and how do we use it?
So, slope would be 1/0.
And how do we use that?
Up 1 and right 2.
Perfect. So up 1, right 2. Do multiple dots. The more dots you do, the better it is. You can also go down 1 and, oops, if I can plot that last dot correctly. Whoa, oh no, my red line's gone. Okay, so the last dot
is down 1, right 2. There you go. And then just label that g of x for me, please. Okay. And it went further and asked you a question. Question number 1, are f and g inverse functions? Are they inverse functions of each other? By the way, how do we know whether a function is inverse of each other or not? What do we have to check? Whether these two are inverses of one another, what do we have to check? It says right here, if a relation, if you have a point A comma B, its inverse should have what? B comma A. So what we want to do is we're going to go in red and find 3 or 4 points to prove, okay? Give me one of the points on the red line. Give me one of the points on the red line. 0, comma 8, perfect. 1 point is not enough to prove. Every single point has to be true. So we'll prove about 3 to 4 points. Give me another point on the red line. -4, comma 2, comma 0. Okay, give me another point. Give me another point on the red. Huh? What?
110.
110. 110, okay, I'll take it. And then I heard someone else that's -5, -2, yeah, that's okay too. I can go down there. -5, -2, okay, 4 points is pretty good. That means every single of those red things or red coordinates that we label, what must be true on the purple? They have to be an inverse, if and only if what? They are switched, okay? So the first point I see is -4, comma 0. Is there a point on the purple that is 0, comma -4?
Yes.
Yeah, we have it already, so check that off. Is there a point on the purple that is 8, comma 0?
Yes.
Is this right here 8, comma 0?
Yes.
Okay, so check. Is there a point on the purple that's 10, comma 1? 10, comma 1, yes or no? Yeah, it's over here. It's my last dot. That's 10, comma 1, even though I don't have it originally, but technically it should be there. So check. Is there a point on the purple that's -2, -5?
Yes.
Okay, is that one right there? -2, -5. Now, if we have time, should every single point on the red, when I flip X and Y, it should be on the purple? Yeah. So if that's yes, then F and G are inverses. So yes. Okay, because how do we justify that G is the inverse of F and vice versa? What do we have to write? Yes, because yes, because the domain of F is the range of what? Of G, and vice versa. Would you guys agree? Okay, so the domain and range, they switch of one another. Okay. Now, so then an inverse function, okay, the domain and range must be switched. Now, for the inverse to be a function, the original must be a 1 to what? 1 to 1. All right. Let's move on. You have a few more definitions to write. I'll move on. I'll scroll it up more once you're done with the first 2 boxes. I know the back is going to have a hard time looking at it. So the back, go ahead and copy that down. Did I hand out tonight's homework already? Yes. Take up some paper, Gemma. Take up some notes. Do something productive, please.
I'll move up a little bit, don't worry. Once. Let's see what more of us are done with the first two boxes.
So when we go back up to the two graphs that Dylan just read, okay, just got done reading. For it to be a function, according to this definition, each x value of the domain must correspond to exactly what?
1.
1. Y. So here you go. It's the random function. No, because how many y value did it correspond to? 2. So therefore, it did not meet the requirement for a function. Number 2, or not number 2, the second box to the right. Can you help me, Hunter, read that box? How do you know a function is 1 to 1?
For a function to be 1 to 1, each y value of the range must also correspond to exactly one x value of the domain.
Very good. Okay, so 1 to 1 function is even stricter. Okay. So not only that 1x maps to 1y, now 1y must also map to what? 1x. So 1 to 1 is even stricter of a function than a function. Now this is where we are, our unit, finding the inverse algebraically. Can you help me read number 1 in finding the inverse function algebraically? Carly, help me read number 1.
Is the function 1 to 1? If yes, continue. If no, stop.
Perfect. Can you see it says if no, don't go any further? Okay. So if yes, then we proceed. Mina, can you help me read number 2, please?
Solve for x. Your input variable now is y. Will you write the function
Perfect. Up until this point, you have always seen y equals. True or false? The reason you see y equals because x is the input. Does that make sense so far? But guess what? Once it's an inverse, what's happening to x and y? It's switched. It's really now x equals. So which one's the input? Y. That's right. So can you see how the notation is now switched? It's really not f of y because y is the input. But here's the difference between what we do with the concept and what the world sees as. When you go take your SAT or your SBAC or whatever test around the world, can you see in our class we rename it as f of y, and y is the new input of our inverse. But in the world, here's the notation of inverse. Can you see that they are using f inverse of x? This is the inverse function of what? Of f, okay? Because it's using the same f. Can you see this? So this is the inverse. This is also the inverse. These two are technically exactly the same. We write it this way because we know the x and y are switched. But the world doesn't really recognize this symbol, guys. The world only recognizes this symbol, f inverse over x. This x is the inverse of the function, of the inverse function. Would you guys agree? Again, this x is the inverse, is the input of the inverse function. But this x is technically what of the regular? It's the y. Okay. So notation-wise in the world, when you take your SAT, it's going to ask you this. Okay. That is the same as f of. That's the same thing as f of y. They are both the inverse function of what? Not of f. Okay. These two are currently the same. Does that make sense? Now both of these are the same, just different way of writing it. This is what it means in our class. This is the inverse function of y. Okay. So this is also the inverse, but it's different ways of writing it. Does that make sense? This is where we're going to stop today. Just talk about the definitions. Go ahead and bust